Alright, let's talk about exponential functions. I'm going to assume that you're comfortable already with the many rules of exponents. And if you're not, there are many videos on the Khan Academy website, and you'll see the links on your worksheet. There are many videos that deal with these rules of exponents. For example, something like a to the x times a to the y equals a to the x plus y. Things like that. A to the minus x equals 1 over a to the x. I'm hoping that you'll get familiarity, or you already have familiarity with these concepts before we talk about functions. Alright, so let's look at an exponential function, and let's start with maybe a good starting point is f of x equals 2 to the x. Now notice, of course, this is not the same as the quadratic function x squared. The input variable here is in the exponent rather than the input variable being in the base. Alright, so f of x equals 2 to the x, and really what I want to do is I want to just talk about the graph and what the graph looks like and why it looks how it does. So let's draw our axes, alright, and I'll make sure I draw all 4 quadrants, but I'm not going to include very much of the negative y values, and we'll see why. So let's just start plotting some points. So let's look at f of 0. Well, f of 0 is 2 to the 0. And as you know, any number raised to the 0 is just 1. So 2 to the 0, f of 0, will always have a height of 1. Now let's look at f of 1. Well, f of 1 is just 2 to the 1, which is 2. So if I have an input of 1 here, then my output should be 2 right there. Let's look at f of 2. Well, that's 2 squared, right? The input number here goes in the exponent. 2 squared is 4. So all of a sudden we're jumping up a lot higher, right? From 1, we went from a height of 1 to a height of 2, and now I'll go all the way up to a height of 4 here. And f of 3, well, that's 2 cubed, that's 8. And I can't even draw this on my scale. It's going to be way up here somewhere. I'll mark a 3 here, but I can't actually draw it there. Let's go the other direction, but maybe before we do that, let's compare how these numbers change. How did I get from 1 to 2? Well, I multiplied by 2. How did I get from 2 to 4? Well, I multiplied by 2 again. And how did I get from 4 to 8? I multiplied by 2. So this function, at least on the right side, every time you increase the input by 1, you multiply. And that's really the key of this exponential function. You multiply the output by the base. And of course, the base in this case is 2. I didn't just want to say the number 2 because it's not always multiplying by 2. It's always multiplying by the base. So let's connect these really quick and see what we get. Well, what we get is something that seems to shoot off. Remember, f of 3 is 8, which is way up here. So we're growing really fast already. Alright, so that's the right side. That's when x is positive. Let's look at when x is negative. So I'll delete these maybe and give us some more space. So let's look at, I'm going to work upwards. Let's look at f of negative 1. Well, that's 2 to the negative 1. But remember, and if you don't, we've got it right here, that's 1 over 2 to the 1 power, so that's 1/2. So f of negative 1 has a height of 1/2, right there. Let's look at f of negative 2. Well, that's 2 to the minus 2, which is 1 over 2 squared, which is 1 over 4. So we're down here. And one more, let's look at f of negative 3. That's 2 to the minus 3, which is 1 over 2 cubed, which is 1 over 8. So when we get input of negative 3, we get an output of 1 over 8. So what are we seeing on the right side, or sorry, the left side? Well, our function is kind of going down and down and down, but it never quite gets to 0. how could we get 0? We'd have to divide by a number larger than any in existence. So we never quite get to 0. Let's look again really quickly at what's going on. So I go from -3 to -2. Oh, look at that. I still multiply by 2. 1/8 times 2 gives me 4. And 1/4 times 2 gives me a half. So I'm still going up. When I increase my input by 1, I'm still increasing my output by multiplying by that base, which is 2. So that's why the graph of an exponential function looks the way it does. Right? It's as we go toward positive x values, as those get bigger, our graph shoots up really high, going off towards positive infinity. And as we take negative x values, our graph shrinks down towards the x-axis. So let me ask you something. Maybe I'll leave it right here. Are there any vertical or horizontal asymptotes? On this function f of x equals 2 to the x. All right, well, a vertical asymptote means that as I get close to a number, my function goes off towards infinity. And if we look, well, our function certainly grows fast as I move to the right, but it's never shooting off towards infinity at a particular number. So actually, there are no vertical asymptotes. How about a horizontal asymptote? Well, notice as I let x get very negative, so as x goes to negative infinity, my function values, they appear to go toward what number? Well, they appear to shrink down and approach 0. So actually, y equals 0 is a horizontal asymptote. All right, so we've seen that this exponential function actually has a horizontal asymptote. Okay, so let's do a quick comparison of a couple different kinds, or not kinds, but a couple different bases for an exponential function. So let's take, as before, f of x is 2 to the x. And then let's take g of x. Let's change the base and say that's 3 to the x. So what are we going to get? Well, let me draw in f of x first. We know it crosses here at 0. And then f of 1 is 2. When I say cross here at 0, I misspoke. The point here is the point 0, 1. So it crosses the y-axis at a height of 1. And then f of 1 is 2. F of 2 is 4. And it quickly climbs out of control upward in a direction kind of like this. Alright, that's the right side of the y-axis, and then the left side, it decreases down to 0, but it never quite reaches like that. Now let's compare f of x to g of x. Well, let's do it the same way by points. G of 0 is 3 to the 0, but remember, anything raised to the 0 is 1. So that y-intercept, the y-intercept is always, no matter what base, the point 0, 1. Because it doesn't matter what number you're using as your base, anything raised to the 0 is equal to 1. Alright, what about g of 1 though? G of 1 is 3 to the 1, which is 3. So we already see that our function appears to be growing faster. And g of 2, that's 3 squared, which is 9, and I can't even draw that already. That's way up here somewhere. So my function is really growing super, super fast. Well, let's look at the other direction. Let's look at negative x values. G of negative 1 is 3 to the minus 1, which is 1 over 3. And that's smaller than 1 over 2. My function is shrinking towards 0 at a greater rate. Right? So you can play around with different bases. You could look at, say, h of x is, I don't know, 1.5 to the x. So that should grow more slowly than 2 to the x. So it should be out here somewhere. But on the other hand, it should also shrink more slowly than 2 to the x. Whoops. Don't want to have them cross, so it should shrink more slowly too. You can see by changing the base, we've changed how quickly our function grows or shrinks.